Hello everyone and welcome back to another video of this NumPy course. So this is going to be the last video of this NumPy playlist, and today in this video we will solve some problems using the NumPy library. Before going into the problems, let me give you a quick recap of what we have learned in NumPy. So we have seen how to create NumPy arrays. Okay, we have seen various methods of creating NumPy arrays. For example, using the range function, and the random number generations is also another way of creating NumPy arrays. Then we have seen how to index NumPy arrays, slice them to basically access the data inside NumPy arrays. Okay, and we have also seen how to modify the data in NumPy arrays. Okay, so to transform the data in NumPy arrays, that comes under modification. Then we have seen some operations on NumPy array, like element-wise operations, and some operations that work on the entire array, like finding out the sum of all the values in a NumPy array. Okay, so these were operations on NumPy array. We have also learned how to combine different arrays into one single arrays. So that comes under merging NumPy arrays. We have seen the vice versa of this operation, that is splitting one array into different arrays based on some index or the number of splits. Okay. We have also seen how to reshape NumPy arrays. That means, for example, this is a 3x2 NumPy array. Reshaping this, we can change it to, for example, 1x6, 1x6. So these kind of operations is called as reshaping NumPy arrays. Fine. So we have seen a lot of these things in NumPy. Now let us jump into the questions today. So we will have a problem statement, something like this, and we will try to come up with some solution in NumPy. So we will use the NumPy library and think about the possible approach to solve the problems. So here is our first question. So in this, we have daily sales of two products, that is pens and notebooks, for 60 days, and we are given this as a list. Okay, and what we are asked to do is we need to calculate the total revenue generated daily from these two products, and we are also given the price of these two products. Okay, and that is fixed. So let us see what we are given here. We have a list, say for example pen, and inside this list we have 60 values. So for each day we have the amount of sale for that particular product. So for example 10, 5, 0, 3, for example, this is our list. So we have 60 values inside this, and each value is the sale at that particular day. So we have for 60 days. Fine. Same for the books list, something like this, for 60 days. And we have another list, that is, I think, cost, and inside this we have a price of book, the pen and book. That is, say a pen cost around 10 rupees and a book cost around 45 rupees. So a list of two elements. The each element is the price of a pen or a book. So this is the price of pen, and this is the price of a book. Okay, so let us go into the Jupyter notebook, and I'll start my Jupyter notebook here. And as always, I will start by importing the NumPy library. Import NumPy as np. So here I have these list already prepared before. So this is the sales of pens for 60 days, and this is the sales of books for 60 days. And this is the cost of the pen and one pen and one book. So it's 10 and 45 respectively. Okay. So let us run this. Now, to calculate the revenue for each day for 60 days, I can simply multiply the cost of one pen, with the amount of pen sold on that day, and plus the cost of one book into the amount of books sold on that day. So I will get the total revenue. For example, let me try this. Say revenue day 1 is equal to pens of first day, number of pens sold on first day, into the cost of pen, that is cost 0, plus books sold on first day into cost of books. So let us see revenue day 1. So this is the revenue for first day. Now I can run a loop and iterate over these lists and just calculate the revenue for each day using this simple logic. Okay, that will work. That is fine. But here we are going to do it using NumPy library. Okay, so we know that when the data will be very large, NumPy library will be very efficient than simple Python loops. So we will think in terms of how we can organize. First, we will organize this data into NumPy arrays, and we will think of what operations we can do to implement the logic, this logic, that for each day the revenue will be this number of pens into the cost and number of books into its cost. So let me now create NumPy arrays for the pens and books. So I will simply write np.array and I will pass the list pens. So this is the pens array. So let me modify this in place, and I will do the same thing for books also. Books. So I have pens and books, and I will like to see the shape of that array. Dot shape. So I have array pens and books. So they are 1D arrays for now. Now I think I can think of some linear algebra way of solving this problem. So what I will do is I will create a 2D NumPy array, something like this, with shape 60 cross 2. So for each day, day 1, 2, 3, for 60 days, I will have the sale values for, in the first column, I will have, say, for example, pen and the books. So I will have two columns in this. So these are the two columns. In this, I have sale values for pen, and this I have sale values for books. And I will create another array, which is 2 cross 1, and I will have the cost of one pen and one book. I think that is 10 and 45. And what I will do is, if I say I multiply these two matrix, this is matrix multiplication, and if I multiply this 60 cross 2 with 2 cross 1, I should be getting a matrix which is 60 cross 1, I guess. Yeah. So each value in this array will be the number of pens, say for example P1 for day 1 and B1 for day 1. So okay, wait, yeah, B1. So each value in this array will be number of pens for day 1 into the cost plus number of books into the cost. So if you multiply this, so this and this, first row, first this column, you will get the revenue for first day. Similarly, the same logic for all the days, and you will get the revenue for each day. Okay. Now let us try to implement this in Jupyter Notebook. So I have created both arrays. Now I want to convert these different individual arrays into one single array, which is 60 cross 2. So I will write np.hstack to horizontal stacking, and I will pass the tuple of both arrays, that is pens and books. I don't know what happened. I think I have to reshape these two arrays. Reshape 60 cross 1. Okay. So yeah, it works. So I have done nothing here but reshaped these 1D arrays into just a matrix with 60 rows and 1 columns. Okay. So then only it will work. So this is the I should call it sales matrix. Okay. So this is the sales matrix, and let me print the shape dot shape. So it has 60 rows and 2 columns. Okay. So first in the first row we have pens, and in the second row we have books. Similarly for this cost list, I would change it. So np.array array costs, and again I will reshape it, because if I don't reshape it, then it will just be a 1D array. So yeah, reshape 2 cross 1, and let's print this. So this is the 2 cross 1 matrix. Fine. Now to do matrix multiplication, I will simply write sales at the rate costs. So this is the revenue list for each day. So it should have total of 60 values. So let's verify this. Dot shape. Yeah, so 60 values and 1 column. Fine. We can also use this np dot matmul and sales comma costs. This is also the same. Okay. So let us store this in a variable called revenue. Revenue is equals to this, and instead of printing, just mention the shape. Okay. Now, let us try to visualize this revenue trend using the a very popular library, visualization library in Python, which is matplotlib. So I will import matplotlib dot pyplot as plt. Okay, I will write plt dot plot revenue and plt dot show. So yeah, this is the revenue trend for 60 days. You can see somewhere it is peaked, somewhere it dips, so something like that. Okay, so we have solved our first question, that is to calculate the wait. Yeah, that is to calculate the total revenue daily for 60 days. Fine. Now let us move on to the second question. And here we have marks data for 100 students in 5 subjects, and it is given to us as a CSV file. So imagine a matrix, something like this, where we have, say, student 1, student 2, like that. We have 100 students, so 100 rows, and we have 5 subjects, so we'll have 5 columns, say, subject 1, subject 2, so 5 subjects. So this is 100 cross 5 matrix, and inside this we have marks for each student for that subject, and the marks is in the range of 0 to 100. Say this is given to us. So what we have to do now is we have to calculate. So we have 3 things to do. Let us start one by one. So first I will import this data, and if you see here, I have this data in this marks underscore data.csv, and I will upload this in on the GitHub, and I will give the link in the description, so you can also download it and use it. So let us just view what this data is. So here we have this name column. This is the name of students, and these are 5 subjects: science, maths, Hindi, English, arts, and we have the marks inside this. So uh, now to read the CSV, this is not a very common way to read CSV files. Actually, we have a very common way, that is using pandas. We read CSV files, but here we have, since we have not covered pandas yet, so I'm just using this np.gen from text method, and I will pass this the path of our file. Now, since this file is in my working directory, so I'm just writing the name of this file, and so this is the name .csv. Delimiter is equals to comma, because this is a comma separated file, so I have to pass this explicitly. I will set dtype is equals to none, so that, because I have a mixed type of data, I have integers also, I have strings also, so that's why. Then I will set encoding is equals to UTF-8. So this is a very standard way. You have to do it every time you import a CSV file into your NumPy array. Okay, so I will run this, and this is the array that we'll get. Let me store this into a variable named data, and I will write the shape of this. So this has 101 rows and 6 columns. So let me take a look on this. So the first row contains the header. Actually, we call this the header row. So let us store the subjects uh, inside this sub variable. And so I want first row, and so first row and all the subject names. So this should fetch the subjects. So here I have. Then we have the names. So let us also store the names in a separate variable. I'll call it names is equals to data, and I want from first row, I want all the names, because here the actual name starts from the second row. So I will write from 1, I want all, and I only want this names column, so I will write 0. And let us print this names. So here I have names in this 1D NumPy. So I have separated the names and the subject names separately in 2 different variables. Now what I have, what I have in this data is the scores that I need to set, that I need to fetch. So I will write data of 1:1:. So yeah, and let me write this in a separate variable, that is marks, and I will like to print this. So these are the marks, and let us see the shape of this. So yeah, now we have this marks matrix, that is 100 cross 5, so 100 students and 5 columns. Okay, now what was our question? Let me see. Yeah, so the first question is, find the average score for each subject. So we have 5 subjects in total, and for each subject we want to find their average score. So yeah, so let's print this marks data. So the first column is for science, the second column is for maths, then third column is for English, fourth is for Hindi, and the last column is for arts. So I will write marks dot mean. Okay, this will not work. I think so. If you see here in the marks data, we have these. Actually, we have these strings. We need to convert them to numbers, integers or float. Anything would work. So I will write marks is equals to, okay, let me change it here only. Marks is equals to marks dot as type. We will use this as type method, and I'll write int. This should work. As type, okay, as type, fine. I'll print the marks. Now they are integers, fine. Because we have all the integers, I already know it before. That's why I have converted to int type. But if I had the decimal values, say 50 point something like that, then it will not work. I should be writing here float or something else. Okay. So this is our marks matrix. Wait. So this is our marks matrix. Okay. Now if I write marks dot mean, so this is the average score of all the students in all subjects. So taking into account all the scores. But I want for each subject. So I can write axis is equals to 1. If I write axis is equals to 1, I will get average score for each student. But I want for each subject. So for each column I want. So for each column I will pass axis is equals to 0. So it will give me average for each column. Yeah. So for, and let me also print the subject. So for science, I have the average score 63.57. For maths, I have 60.4. English, it is 66.97. So we have calculated the average score for each subject. Now, let us see the next task, that is identify subject-wise toppers. Subject-wise toppers. So what it means, so in each subject, we have to find uh, the toppers. Okay. So say for example, if I write marks dot max, I should write marks dot max axis is equals to 0. So these are the top scores for each subject. So I just need to find out all the students who scored a perfect 100. Okay. So for that, so I would write marks dot max axis is equals to I will write marks dot argmax axis is equals to 0. So these are the index for the students which scored the highest marks in these subjects, 5 subjects. And I would like to access the names for these students. So I would write in the names array, I would simply pass this index. So I will pass this index and I will get the names. So Noah, Olivia, Avery, and Olivia. You can see Olivia has scored a perfect 100 in 3 subjects. So that's why it's coming 3 times. Okay. So these are the students that scored a perfect 100 in the respective subjects. Like if I print the subject, so in science, Noah was the topper. In maths, Olivia was the topper. In English, Avery was the topper, and so on. Fine. So with that, we have solved this second question also. Now, in the last task, we want to find for each student, find the maximum score subject. That means for each student, we want to find what is the subject in which they scored highest. For example, for student 1, he scored maximum in, say, English. For student 2, he scored maximum in, say, maths. So for like that, we have to do for all the 100 students. So let us see how we can do that. So we have this marks matrix, and say if I write marks dot argmax, I want to find the maximum score for each student. So for each row, I will write axis is equals to 1. So for each student, I have the index of the subject in which they scored highest. So, okay, but I want the names also, and I want to print the subject. I want to print the subject beside that name. So I would write, say, let me fetch the subjects. If I just pass it to the subject matrix, so these are the subjects, and so let me write the loop for name comma subject in zip names and the subject print sorry print name comma s. So yeah, so the student Oliver scored highest in English, student Ema scored highest in arts, student Liam scored highest in maths. So for each student I have displayed the subject in which they scored highest. So Yeah, we have solved our third task as well. Now let us move on to our third problem statement. That is, in a hospital laboratory, we want to determine how many patients underwent 3 different medical tests in a day. So we have 3 tests in a hospital: blood test, X-rays, and MRI scans. And at the end of the day, they only know the aggregate operational data. So we don't know how many patients did blood tests, how many patients did X-rays, and how many patients did MRI scans. So, but we have this data that is given to us. So total patients were 180. So let us just denote, say, blood test patients, number of blood test patients as X, X-ray patients as Y, and MRI scans as Z. So total patients were 180. So we can write this equation as X plus Y plus Z is equals to 180. So this is a valid equation. Okay, let me change this. This equals to 180. So number of blood test patients plus X-ray patients plus MRI scan patients is equals to 180. So this should follow because total patients are 180. That's why. Now, total technician time consumed is 390 hours. Okay, we will take this data. Now, here we are given for each test the time it consumed. So, a blood test takes 1 hour, X-ray takes 2 hours, and MRI takes 4 hours. So, if we have denoted these as XYZ, we can write blood tests into 1 plus X-rays into 2 plus MRIs into 4 should sum to 390. Okay. And here we are also given the billing amount, that is somewhere around like 1.53 million. So, and we are given this data. So blood test cost 2000 and X-ray cost 5000, MRI cost 12,000. So we can sum the cost like this. So 2000 plus Y into 5000 plus Z into 12,000 is equals to 1530. Yeah. So we need to find X, Y, and Z. That means we need to find the patient who took blood test, patients who took X-rays, and the patients who took MRI scans. So let us first write this equation here in our notebook. So I have written this question here also. Let us first write the equation. So let us write the equations here. X plus Y plus Z is equals to 180. Then we have the hours, that is X plus 2Y plus 4Z is equals to 390, and we have the total cost, that is 2000x plus 5000y plus 12,000z, and the total cost is around 153000. Yeah, so let us just comment this out. This is the equation that we have created. Now we will try to solve this equation in NumPy. So this is just a simple linear equation, and we have 3 variables x, y, z. So we have to find the solution to these 3 equations. So let us create a matrix for these, and to create the matrix, I would write np.array, and I will create a 2D matrix. So in the first row, I will have the coefficients for the first equation, that is 1, 1, 1. In the second row, I will have coefficients for the second equations, that is 1, 2, 4. And in the last row, I will have the coefficients for third equation, 2000, 5000, and 12,000. So this is one matrix. Let us call this coefficients. Coef is equals to this. Then let's create another matrix, and it will just be 3 cross 1, and I will like to store these values. Okay, so these are the data that we are given, and we are just storing it in some form. Okay, that is how we are trying to approach this problem. Okay, so I will call them, I should say, values is equal to np.array, and here we have 180, then we have 390, then 153, and like this. I forgot the comma here. Yeah, and let us just reshape this into 3 cross 1. Okay, because we want to do some matrix operation further, so this should work fine. That's why we are changing it to a matrix which has 3 rows and 1 columns. Okay, now let us try to visualize this. So this is our coefficient matrix, and we have our values matrix. Now in linear algebra, how we solve these linear equations is, so we have created matrices. Our coefficient matrix is 3 cross 3, and our values matrix is 3 cross 1, 180, 390, and 15 point, sorry, 1.53, 1.53 million. I'm just writing it in short form. Okay. So these are the coefficients 111, 124, 2000. Let me write this 2K, 4K, sorry, 5K, and 12K. And I'll create another matrix X, Y, Z. So if you write this way, so these two matrix, if we multiply these two matrix, I will get a matrix in which I will have these three equations. If you visualize the multiplication, I will have these three equations, X plus Y plus Z, and I will equate this to the values, this. So I have converted the given equation. So what was the given equation? These were the equations that I have constructed from the problem statement. Then I converted the values to coefficients and the given values to this values. Okay. I think if we multiply these two matrix, I should get these two this values matrix. So the coefficient matrix times, let us call this capital X matrix, is equals to our values matrix. And we can solve it by writing X is equals to coefficient inverse values. So we first have to find the inverse of this coefficient matrix and multiply this with values matrix, and we'll get our solution X. So let us try to solve this. I will use np.linalg.inverse, and I will write so inverse of coefficient, and I will multiply this with values. So these are the values that I get. Why am I getting negative value? I need to find out. Maybe there is something wrong with the data. Maybe. Now let us move to our last question, and that is a little bit interesting because it involves convolution. Now the question says, fetch the last 5 years Apple stock price and try to obtain a smooth curve for that. Okay. So this is a photo of the last 5 years stock price for Apple. 5 years. Okay. We need to find a smooth curve for this trend, for this chart. So I mean something like this, something like this. So basically we want to filter out high frequency signal and just keep the low frequency signal. So you can think of these values as mix of high frequency and low frequency signals, and we just want a lower frequency signals. I mean, these, you can see these fluctuations. We don't want to see these short term fluctuations. We want to kind of get a bigger picture of this overall trend. One more example could be, say, for example, something like say a more detailed one. Okay, something like this. So in this, we are capturing more bit high frequency values. Okay, so this red curve captures more high frequency values, high frequency values. This green curve, it allows only low frequency values to pass, low frequency values, and this actual data has all the high frequencies and low frequency components also. So this is the idea that we want to do in NumPy. So let us try to do this. I'll fetch the Apple stock price for the last 5 years. I will use this import yfinance library. I will import it as yf. And if it is not installed, you'll have to first use pip install yfinance. Since it is already installed on my laptop, so I don't need to install it again. So I will just delete this cell. So import yfinance as yf, and this is the code to fetch that stock data. You have to write this directly. So I will call yf.download, and I will pass the stock name, and I will specify how much years data I want. So I will write 5y, and I will pass how frequent I want the data. So I want daily data, and I will pass this stock name. So here I will specify the stock. Since we are working on this Apple stock, so I will write APPLE. Okay. it gave us error. So we can't simply write the name. We will actually have to look for something called a sticker. So I will write Apple by finance sticker. So you will have to pick this name, what you see in this parenthesis, AAPL in capitals. Only then you will able to download that company's stock price data. Exactly that you will have to write here. Now it works. Yeah. Uh, so what we get here is actually a pandas data frame. Now, since we have not covered that, so I will have to convert it first to a numpy array using this 2_numpy. I will first take only the closing price. So let me just let you see the data frame. This is actually a pandas data frame, and I only want this closing price for each day. So I'm first selecting this column. So for that, I just write close. So this is this column that I select, and if I write .2_numpy, I get this as a numpy array, which is I will have to see the shape. So I will write prices. So this is the stock prices. If I do shape, so it has around 1256 days. The this much days data we have for Apple stock. Let us just convert it to a simple 1D array because we are going to further do convolution on this. So for that we are doing this. Prices is equals to prices dot reshape minus 1 prices. So yeah, this is a 1D array now. Now I will have to show you what are we going to do to obtain these smooth curves. So there is something called as convolution, and it works like this. Say for example, we have two lists. Let me write this. Okay, I will write it on a new page. So for example, we have two data lists. Say here we have the values, and to find a smooth curve for this. So this is our Apple stock prices, right? Apple stock price for 1256 days, I guess. Yeah, for 5 years. Okay. So this is our Apple stock price, and if we want to find a smooth curve for that, I will do something called as convolution operation. Now, convolution might seem a fancy word, but basically it's just dot product between two arrays. And the second array I will take it is something called as kernel, and it will be it will have some 200 values, so 200 size. So I will do dot product between the first 200 values in the stock price and this 200 values, and I will store it in some third array that let us call it result array. So dot product of this kernel with the values up to here, I will store it here. Then in the next step, let me select this. Yeah, then in the next step, I will slide this kernel. Okay, slide this kernel, and I will calculate same way I will calculate the second value. So I will keep on doing this until I reach the end of this array like this. I will keep on sliding, and I will keep on calculating the values. So we are not going to do this mechanism manually. I will just call one method in a numpy array. Sorry, a numpy library. I will just call np dot convolve, and I will pass this prices. This is our first array on which we want to do convolution. And there is one more array that is called kernel. First, I need to create the kernel. Say kernel is equals to. So for this smoothing operation, I will choose Gaussian kernel, and its function would be. So its function would be. It's actually 1 by under root 2 pi sigma e to the power minus 1 by 2 x minus mu by sigma whole square. But we will take a simpler form of this. I will just write e to the power minus x by sigma whole square. So it looks something like this, a normal distribution, something like this. So this means using this, we are going to filter high frequency trend from this chart and just keep low frequency overall trend. Okay. So this is the idea. So I will create kernel is equals to, I will use np dot exp, and I will write minus x by sigma square. Now, what is this x and sigma? So x is the our number line. I will just create, say for example, np dot line space, and I will write, say for example, minus 3 to 3. I want 200 values, and sigma is chosen by us. to actually tweak the variance or spread of that curve. So let me show you. If I write sigma is equals to 1 and this is our kernel, and let us plot this kernel, plt dot plot kernel. So this is our Gaussian kernel. Okay, I showed you on the board. If I write sigma is equals to 2 and I plot this again, so now you see this is more spread. And if I write sigma is equals to 0.4 and if I plot this, so this is more peaked kernel. So using this sigma, we are going to get different frequency charts. Okay, so for example, if I set sigma to some high value, I will get this green curve, something like this. Okay, if I set frequency to some lower value, I will get this red kind of curve. Okay, so it depends on us how much detail we want to keep in our smooth curve. So all that we are doing is to filter high frequencies and only keep lower frequency, and that depends on us, and this depends on this variable sigma. So let us just keep for simplicity sigma equals to 1, and then we later on tweak this sigma value. Okay, so this is the plot for sigma equals 1. Now I will want to convolve this prices with kernel, and I will set the mode is equals to say valid. There are three different types of modes in convolution. If you know convolution, then actually convolution results in a different size result, different size than the size of price. So to handle that we'll write valid, or I can write same, and I will store this into result variable. The result is equals to this, and I will plot this, plot result. So it says, sorry, plot result. So I think we are getting this smooth curve, but I can see this sudden increase and fall, which is not actually the case in my stock price chart. I just forgot to plot that chart. I'll write plt dot plot and prices. So this is the stock price for Apple for last 5 years. Okay, this is the stock prices, and this is the smooth version of that. But actually, if you see, there is no sudden abrupt change in the endpoints. I want something like this. So for example, I want something like I have to change the color, something like this, a smooth version of this graph. Okay, but what is happening actually is that I am getting these abrupt changes here. So to solve this, I will do something called as padding. Now, padding simply means to extend the prices array so that it matches the kernel of the convolution operation. So you just have to keep that in mind. I'll use np.pad, and I will pad the prices array, 100 values on both the side, and it will just extend the end values and just repeat it 100 times on each side of that array. 100, and I'll say mode is equals to edge. So edge. Okay. Now let us visualize the result again. I think I will have to write valid here. Yeah, so this is it. Let me also plot that actual stock price chart and compare it with that. Mm, I will I will just copy paste that, and I will plot on that. I'll plot this plot result. I think the scale of this smooth plot is completely different. Now to resolve that, uh, I will have to change this kernel a little bit. I will just have to divide this kernel by the sum of the values in that kernel. Why I'm doing this? Because to scale down this kernel so that just like that we can see this smooth curve here, we can see this actual on the stock price chart also. So if you see here, the values are completely different, but in the actual stock price chart we have these values from 125 to 300. So on that scale, to bring it on that scale, I have to change the kernel a little bit. I'll simply divide the kernel by this sum. So the sum of the kernel should be 1. Let us plot then again. It looks similar, no change. Let us do convolution here. Here also we don't see any change. If I plot this, you can see now we can get that type of curve now, smooth curve. Okay. Let me change the color also, and I will do dash red. And I want to make this stock price chart a little bit blur. So I will write alpha is equals to 0.3 or say 0.4. So now we can see it more clear. So this dash line is our smooth curve, If we want to change the, I showed this on your on the board, this high frequency, this low frequency. We can tweak that using the sigma values. Okay, so keep this chart here and let us do this thing again, but now with a different sigma value. Let us copy paste here, this also, then I will paste to plot the chart. Fine. Okay, yeah, let us plot it. So now we are going to tweak this sigma value. Now you see the smoothness of this curve. Now I will change the sigma, say I will start with a lower value, say 0.1. Now 0.1 is a very peaked Gaussian curve. I've shown you before. So it will capture high frequency values also. So now you see this red curve. It is capturing these volatilities, small fluctuations, short-term fluctuations also. But we don't want that. We want some smooth form of this curve. So I would keep on increasing this, say 0.5. Now it is capturing less volatility. Okay, now it is a bit more stable, we can say, less noisy, we can say. But I want, say, only this type of trend. I want something like this bigger view trend. So let us do that. I will just keep increasing the sigma value. Say I will write now 2. Yeah, this is much better, I guess. Okay, so we have solved our last question also. This operation is called convolution, and it's technically it is termed as filtering the signal. It is also called as high pass filter, I guess. Yeah, this does the function of high pass filtering because it filters the high frequency fluctuations, and we only get smooth overall big, you can say, overall bird's eye view trend. So yeah, I think we have made it to the end of this video. I really hope that you enjoyed watching this playlist, and this is the last video of this playlist. We have completed our NumPy playlist here. So yeah, keep learning, and thank you for watching this video.